In this premium Paracourse lesson, we want to fabricate a polyhedron in Grasshopper. Actually, we're going to define different polyhedrons and make these connections in Grasshopper, then put them on the ground. You can see that we need 60 of these connections, and also all of these faces are the same for this one, so you can see you can use this curve for fabrication. I have put also different polyhedrons in the example file, so if I just put this one, you can see we can also fabricate this. We can define the thickness, maybe we can decrease that to 0.1. Okay. There is also an offset, which is the distance between the faces, so I can increase that to 0.2. The length of this connection, so maybe we can put that to 1.2. And also the location of these, so I can just move them like back, like that. This is based on the polyhedron we are using, because maybe if we have a small face, they are going to intersect and we will have problems in the curves. You can see that I have extracted these curves on the ground and also the number we have. We're going to explain how we can find that and move the location so they're not going to intersect and have them here. Okay, let's connect another polyhedron here to the connections and check this out. Okay, and you can see that this is another polyhedron and we have these faces on the ground ready for fabrication. We can also increase the thickness maybe a little bit and change the final results. You can see that the thickness has also increased. And another polyhedron we can connect here. At the first step, I'm going to explain how we can use a plugin to produce different polyhedrons. Again, in this one, remember that the size of these faces is really important. For example, this one, you can see it's too small to get the final results. So what we can do here is to change the location of these things. For example, what we can do is to decrease the length to maybe 0.8, decrease the offset, and also the location of these sections. So I'm going to play with this location 0.3 and bring them a little bit to the middle of the edge so they don't intersect with each other. Then you can also play with the thickness and those inputs. Okay, that's it. You can see that we can have the final results, and on the ground these are the numbers of the sections we need. All of them are the same because we're going to use a unique technique to extract the connections. And again, in the definition we can go here, which I'm going to explain, and decrease the distance between these sections. Okay, and we have all of these sections that we want to fabricate. So before we start this premium tutorial, what we want to do is to also let me just disable this one and talk about the polyhedron plugin. First, at the first step, I'm going to explain how you can use the polyhedron plugin, which is going to go inside the meshes polyhedron. We're going to use this polyhedron plugin to produce different polyhedrons and then connect them together, get it ready for the base algorithm, which we can change. Okay, you can change the size. You can see we can select between different polyhedrons and sizes. For example, I want to use this one. I can make this a little bit larger and then give it to the algorithm and enable this. Okay, let's go for the first step. What we want to do is to make the polyhedron plugin work, but before that, let's just check that out. That's really great. Everything is working fine. We have these intersections, we have all of the sections on the ground, and we have the numbers. You can see that we have the numbers also on each faces. So let's get started from scratch. What I want to do is to show you the first step, which is using the Polyhedron plugin. You can go here and use this polyhedron. Put it on the canvas. Okay. There is a name input which we have to define which of the polyhedrons we need. So I'm going to go to the polyhedron and select these two things, polyhedron categories and polyhedron names. So let's just do that, categories and names. Okay, give the category here. It's going to give us some names here. We can see that all of those 1270 polyhedrons are in groups. I'm going to right click and simplify this, so it's going to make that. Here you can see that it's going to completely simplify the outputs. We have 44 groups, so how can we select between these groups? One of the easiest way we can do that is to go to the sets, and in the tree I'm going to use this tree item. That means we're going to pick up from one of the groups and one of the items. That is exactly what we need. Give it here. Okay, because we have 44, I'm going to make 0 between 44. If I give that, that's going to select from the path. There is different numbers of polyhedrons in each group. The first one is a little bit too much, but others is between something like 30, like that. So I'm going to make a number slider between 0 and 30. You can increase or decrease that if you want to, but for now we're going to give that name to the name inputs. Okay, here we have the size. Now for the plane, the default is in XY plane, and the scale is also, let me just make this a little bit bigger so we can work on the faces and get the results. Okay, for example, this is one of the polyhedrons. We can play with these numbers and get different results. I guess this one can also be used and can give us different results. Okay, let's stick to a simple one so we can understand the faces. I guess that this is not bad. Let's work with this one. So from the output there is a curve, a mesh, and a solid. The solid says that is it a solid? It's true. You have to use those polyhedrons that don't intersect. For example, if I go to these numbers and I change that, you can see that these polyhedrons are not going to help us, because you can see even the solid is also false, and then we're not going to get final results. Okay, let's bring that back to 14. There is a curve, there is a mesh. What I want to do is to connect that curve to a surface from the geometry, and that's going to give and convert that into a face, and then we can join all of them to have a complete B-rep. The reason is, in this next steps I'm going to explain that we need a complete closed B-rep for intersection. So I'm going to go to the surface, utility, and join them together. Okay, that's the first step, and that's going to actually give us the complete solid closed B-rep which we need. That's for the first step, and I can bake that and have that in Rhino. That is the first step. In the next step we're going to analyze this solid to get the faces and start modeling the joints. Let's go to the next step.